In this video we're going to look at rationalizing the denominator in surd expressions. So let's just think about what those two words mean, rationalizing and denominator. So for example, if we've got 3 divided by the square root of 2, this is a fraction, and we know that the top of the fraction is called the numerator, so you've got a numerator on top, and the bottom of the fraction is the denominator. So what we're going to do is to try and change the denominator, and what we're going to do to it is to rationalize it. What that means is to make this into a rational number. So at the moment it's the square root of 2, which isn't rational. Something like a rational number might be a half or 5 or 7. But basically you're going to turn this into an integer here, and the way we do that is to, in this sort of case, where we've just got a surd on its own on the bottom, on the denominator, is to multiply top and bottom of the fraction by that surd that's on the denominator. So here the square root of 2, so I'm going to get 3 root 2 divided by root 2 times root 2, and root 2 times root 2 is 2, so that's 3 root 2 over 2. And now the denominator is a nicer number, it's a rational number. Another way we could write that is 3 over 2, or 1.5 times the square root of 2. And I suppose that's really why we want to rationalise the denominator, because we get a bit more of a feel for what the number is. Dividing by the square root of 2 is a very awkward thing to do, whereas here I'm just saying, okay, I've got the square root of 2 and I've got 1.5 lots of it. I've got 3 over 2 times root 2, so in some sense that's a bit simpler. So let's take another example. If we do 12 divided by the square root of 3, again, I can just multiply top and bottom by the square root of 3, and that will rationalise it. So 12 root 3 divided by root 3 times root 3, and that's 12 root 3 over 3. And now we can simplify this fraction by dividing top and bottom of the fraction by 3. So that's 4 root 3. Notice I'm not doing anything here that you haven't been doing to fractions for a long time. I'm just multiplying or dividing top and bottom of the fraction by the same number, and we know that that gives us an equivalent fraction. It doesn't change the value of the fraction. So another example, 17 divided by the square root of 7. Now this time we'll multiply top and bottom then by the square root of 7. 17 root 7 over root 7 times root 7. So that's 17 root 7 over 7. So let's look at some trickier cases. So what about if we had 2 divided by the square root of 3 plus 1? Now here, just multiplying top and bottom by the square root of 3 isn't going to do it, because I'd end up with 2 root 3. I'd have to multiply everything on the bottom by root 3, and I'd get 3 plus root 3. It would still have a surd in the denominator. If you've watched the video on multiplying surds, you'll know about the difference of two squares types of expressions, and that's what we're going to use here. So I'm going to multiply numerator and denominator by the square root of 3 minus 1, and the bottom by the square root of 3 plus 1 times the square root of 3 minus 1. So essentially I've just taken the expression here, turned the plus into a minus. If it was a minus, I'd have turned it into a plus, and that's the thing that I multiply by. And the reason that works so nicely is because that this denominator here is a difference of two squares expression, DOTS for short. And when I do, so when I multiply out the square root of 3 plus 1 times the square root of 3 minus 1, what we get is square root of 3 times the square root of 3, which is 3, plus root 3 and minus root 3, and they cancel out. And then plus 1 times minus 1 is minus 1, so I end up with root 3 squared, which is 3, minus 1 squared, which is 1, so 2. So actually when I rewrite this out, I've got 2 times the square root of 3 minus 1, and this denominator is just simply 2. So the 2's cancel and we get square root of 3 minus 1. A nice simple answer there. Let's take another example just like that. So if I do 3 divided by 2 minus the square root of 3, that's going to be then, I'm going to multiply top and bottom by the thing to make the difference of two squares on the bottom. So 2 minus root 3, I'm going to change the minus to a plus and use that. So I'll multiply the top by 2 plus root 3 and also multiply the bottom by 2 plus root 3. And then what we get is 3 times 2 plus root 3. On the bottom we've got 2 squared minus root 3 squared, which is 4 minus 3, which is just 1. So I actually end up with here 3 times 2 plus the square root of 3. If you wanted to, you could write that as 6 plus 3 root 3, multiplying out the brackets. Let's do one harder example that combines together ideas from this video and one of the previous ones. So let's have a look if I did 6 root 2 minus the square root of 8. So 6 divided by root 2 minus the square root of 8. This one on the left I can rationalize and say, well, that's 6 root 2 divided by root 2 times root 2. And the square root of 8 we can write as the square root of 4 times the square root of 2. I've done that because the square root of 4 is just 2. So 6 root 2 over root 2 times root 2, that's 6 root 2 over 2, and this is 2 root 2. So I get 6 divided by 2 is 3, that's 3 root 2 minus 2 root 2, so that's just 3 minus 2, which is 1, or 1 lot of root 2, which I just write as root 2. So all of these tools we've got allow us to simplify surd expressions here. What looked like quite a complicated expression actually turned out to simplify down to something incredibly simple, just the square root of